Today's lesson is going to be on solving one-step equations. When I think of equations, I like to think of a balance scale like this one. And what this means is whatever you put in this pan has to equal the other pan as long as these levels are the same. So what I would like you to do is to make a great big equal sign on this balance scale right here to show that these are equal. And what I can do, I'm going to put an X, and then I'm going to put 2 1s right here on the left-hand scale. You can do the same. On the right, I am going to put 6 little 1s. What this says algebraically is that my X and my 2 are equal to 6 right here. This is my equation. My goal in solving an equation is to figure out X equals something. So right now I have X plus 2 on the left. I only want X on the left. I want X to equal something. So you know what I would do? Physically, I would come and I would take away those 2 1s to get X by itself. But what happens? The scale would tip. This is what it would now look like. And we don't want that. So what I can do, if I take 2 away on this side, to keep it even, I'm going to take 2 away on this side. That's visually what's happening when you solve an equation. So now let me show you. I like, with the equal sign, to draw a line, and that makes me remember about this balance scale. Whatever I do on one side, I have to do to the other. So if I'm going to take 2 away on the left so that I can get X by itself, I also have to take 2 away on the right to keep that equal sign even. These 2's, 2 minus 2, as we saw right here, it equals 0. So all I'm left with is X on the left. Bring down my equal sign. 6 minus 2 is 4. As I'm showing you how to solve these equations, it's going to be important that you write this down just like I do. This is going to help when the equations get harder and in your next few years in math to have a system and a process for showing your work in solving equations. What we now do after we solve an equation, can't talk right now, we check it. Here's how we check the equation. We're going to write down the original equation, X plus 2 equals 6. Now we think that X is equal to 4. So our next step is we're going to substitute in here. We think that 4 is equal to X. So the question is, 4 plus 2, does that equal 6? This is how we check. Well, yes, 4 plus 2 is 6. So both sides of the equation equal each other and it checks. The rule of equations is as follows. Write this down in your notes. Whatever you do to one side of the equation, you have to do it to the other side. And right now I'm going to show you how we're going to undo operations to get the variable by itself. In the example I just showed you, it was X plus 2. To undo that, we subtracted 2. So the opposite of adding is subtracting. So let's try y minus 3 equals negative 2. So we have our variable, y. We are subtracting 3. The opposite of subtracting 3 is adding 3. I'm going to draw my line to show that we have equal on either sides. I am going to add 3 to both sides. Right here, negative 3 plus 3 is 0. So all we're left with is y equals, and you can use your calculator, negative 2 plus 3 is 1. We're going to check this. The way we check it is we're going to rewrite the original equation. We think y is 1, so we're going to substitute in a 1 there, 1 minus 3, and we're going to see, does this equal negative 2? Yes, it does. Both sides match, so we know we have the correct answer for our equation. What about with multiplication? So 4m, this is 4 times m, equals 24. Now, what's the opposite of multiplying? We have our variable we're multiplying by 4. Divide by 4. And please notice the way that I'm writing this. I want you to write divided by 4, kind of like a fraction. If we do it on the left, we have to divide by 4 on the right as well. Well, 4 divided by 4 is 1. So we're left with 1m on the left. 24 divided by 4 is 6. Now we're going to check our equation by rewriting the original equation that was given to us. We think m is 6, so we are going to substitute. We're going to take out the variable and we're going to plug in a 6 because that's what we think the variable is equal to. So the question is 4 times 6 equal to 24? It is, and it checks. One more, if we have a variable divided by 3 equal to 10. So what you can do is you can ask yourself, well, what's happening to the variable? In this case, it's being divided by 3. The opposite of dividing by 3 is multiplying by 3. So notice how I'm using my parentheses to show multiplication. I'm multiplying by 3 on the left, which means I need to multiply by 3 on the right. The reason why I multiplied by 3, you can think about this as 3 over 1. If we cross simplify, those cancel out. We're left with our variable is equal to 30. Now we are going to check by rewriting the original equation as it was given to us. We think d is equal to 30, so we are going to substitute in 30 divided by 3. Does that equal 10? Yes, it does. That means both sides match, so we have a correct answer here.